Hey Mr. Mac, I cannot wait to start the CO2 car unit today. Students really like this unit, Mr. Zeus. They are engaged from the beginning, researching, sketching and designing their prototypes. Constructing and testing the CO2 cars is always fun. The next slide will review the unit goals.
Let's see where Mr. Zeus and I would have for expectations. And that's for you guys to work in a team environment. Research and describe what the force effects are going to be on the vehicle and keeping the data of what you think is going to happen. Design process and making up working sketches of your dream of what the car is going to look like. Then actually taking that sketch and making it an actual working drawing, full-size graphs that can go right on the blocks. Selecting the right hand tools and power tools to really make that car be cut out of the block of wood and come to be where you want it to be. Then demonstrating the safe work habits that you have to have out in the lab. You know what that is, wearing your safety glasses all the time and making sure you're protected. How to design the mass, friction, and balance as it relates to performance. What did you do and how did you do it? Demonstrating and understanding what the quality of craftsmanship is. Making the car come out looking the best that it can. Problem solving and making modifications to improve how that car is going to go on the ramp test as straight as possible. Here's a quick quiz for you. Answer these questions with the information that you already know. Let's see what you got for answers. Here's how the design process works. Look at the bubbles on the right-hand side. They flow left to right and top to bottom if you look at the way the arrows go. In each activity, you're going to make them flow from top to bottom in the activities, but they will give you more and more information to work with. Completing your written critique at the end will be all the information you gather from Activity 1 through Activity 9. Good luck! See the aerodynamics and how it works around this vehicle in the video. Look at your car. See how yours is going to have the aerodynamics flow over the top of it. And see how each one of these words plays a role in the aerodynamics of your vehicle ready to go down the track.
We have attached a downloadable copy of the lab product descriptors that you see on the slide so that you may print and keep a hard copy of the items in your binder.
We are now entering Learning Outcomes Part 2, the Designing segment.
During this stage, the intention is for you to draw a series of quick, small thumbnails. Capture your ideas on paper. Only basic details are needed. Pick your favorite design from all of the thumbnail sketches that you captured, and now it's time to sketch to scale. Using the designated project specifications that is attached to this slide, you may download a copy. Measure your dragster block, draw the top view and the side view. Make sure you measure the depth and location of your cartridge hole. Draw the outlines, verify your measurements. Cut your paper template and tape the top and side views to the block. Align your template with the center hole of the block. Trace it out. Make sure you mark where the axle holes will be drilled. It's time to remove the template and drill the holes. Let's have everybody participate in this very short poll.
Okay, let's get started in the shop. It's time to cut and drill the holes for the CO2 cartridge and the wheels for the axles. Let's go out in the shop and go to the drill press, and we'll set this up, and each one of you will drill out those items. Remember, safety first, and don't be in a rush. Let's take our time and do this right.
It's time to do a short quick write. Please record the step-by-step procedures from rough block 2 holes drill. Don't forget to include materials and tools used so far during your process. What safety features did you use? And we appreciate it if you would make a bulleted list.
Now it's time to cut the car out of the block. Let's go out to the bandsaw, follow the lines that you've got on the block of wood, and we'll cut it out so that it comes out to the shape that you want. Let's be careful out there, follow all the safety rules, and let's not be in a rush. Let's go have some fun.
It's now time to start putting some shape to those cut pieces. Remember your safety rules and be meticulous with your work. Please update your quick write and talk about the tool safety, accessories that you used, how you are shaping your body, and how you're getting your body smooth. Again, please use bullets. Learning Outcomes, Part 3. This is where you're putting it all together. You're continuing to apply safety rules while using the tools, fine-tuning your design, and getting the performance that you're expecting.
Ramp test. Let's take a look at how your car goes straight or doesn't go straight. Let's figure out why it doesn't or why it does, and if you have to make any improvements or any alterations to it. Make any adjustments that are ready to go. This is the final chance you have before the final assembly and the finishing of the car. You want it perfect right now. This is the time to look at all those details. Work with each other and improve each other's cars.
This is an important step to get the high quality primer finish that you're hoping for. Remove all the small scratches, blemishes, and marks for the ultimate dragster body. Patience will be very useful at this stage. You need to prime and wait. Prime and wait. Then sand. More patience. You want that ultimate look, don't you? Add those fine details and own that car. Make your personality come out in your design. Clean and trim those axle holes. We don't want any friction. Here's another quick test. Go ahead and pick the right answer.
Okay, now it's time to finalize the lab report. Let's look at all these questions on this slide. You have all the information that you've collected over the whole class time of this unit for this project, and let's put it all together in this lab report and finish the job. Your cars have come out great, they ran great, they really look great. I know you enjoyed it, and now it's time to bring this report and you have a complete and finished project. You all did a great job. Thanks for being here.
Hi Jennifer, how did your car perform?
My car finished in second place. Did your design help your car move fast?
Well, my design was aerodynamically sweet, the grams were well within the specs and I had no drag issues. I should have spent more time with wheel alignment. I still had some friction between the string and the screw eye.
I was really nervous during the trials.
Trial runs were the best. I really appreciate knowing how to safely use tools.
I agree. See you later.
Nice work, everybody. We were very pleased to see a very friendly, collaborative effort throughout this car unit.